In section 8-7, you're going to learn how to factor special cases. Now I want to take a moment and rewind and make sure you remember what a special case was. Do you remember when we would have x plus 4 the quantity squared? And then I told you could either A, remember your shortcut, and or B, just write it twice, like this, and then you would factor it. Okay? So let's go ahead and practice that. That would have been x squared plus 4x plus 16, and then you would combine your like terms and get x plus 8x, x squared plus 8x plus 16. So that was one of the special cases. Now, if you guys remembered the special rule, okay, let's talk about the special rule. If you remembered how to use your special rule, you learned that you could just square the first, and then you could add, or whatever that symbol is right there, you would add or subtract 2 times these things multiplied together. So 2 times 4 times x, so you would do 8x, and then you would square the last one. Okay, that was one special case you learned about back in, I think it was 8-5. The other special case you learned about was something like this, where you had x plus 3 and x minus 3. And you would either A, remember the shortcut, or B, do it the long way. Either way, you would end up getting x squared minus 9, because the middle 2 terms would cancel out. So what we're going to do today, guys, is I'm going to give you the trinomial or the binomial, and you're going to work backwards to get the factored form. Okay, so we're still working backwards. What I explained up here is exactly what this chart says. Now what you have to remember to check for is, check number 1, is the first term a perfect square? Okay, that's your first check. Check number 2, is the last number a perfect square? And being a perfect square, you should remember, that should be a positive. The last check you need to do is check the middle stuff. Is the middle stuff 2 times the square root of the first times the last? If so, you can use the shortcut. Now guys, just like I taught you before, if you don't remember the shortcut from today, that's fine. It might take you a little longer, but you're still going to get there. I want to make sure you understand when you can and cannot use the shortcut. Let's pretend you have x squared plus 10x plus 25. Let's see if you would be allowed to use the shortcut I'm going to teach you today. Is x squared a perfect square? Yes, of x. Is 25 a perfect square? Yes, of 5. Is 10 2 times 5 and x? Yes. So you could use the shortcut in this problem. Let's try one more example, and I want to make sure you're good with why it wouldn't work. X squared plus 10x plus 16. Well, x squared is the perfect square of x. 16 is the perfect square of 4. But is 10 2 times 4x? The answer to that is no. So this one could not use the rule today. Could you still factor it? Absolutely. Could you use the shortcut? No. Let's take a look at problem 1. What is the factored form of x squared minus 12x plus 36? Let's see, number 1, if you can do this, how I taught you in 8-5. Alright, here we go. In 8-5, I would say, guys, I want you to pick numbers that multiply to positive 36, but add to negative 12. Hopefully you would have told me 6 and 6, and they would both have to be negative. And then you would factor it to x minus 6 and x minus 6. And then you could rewrite that as x minus 6, the quantity squared. But if you could notice, this does use the shortcut from today. Let's rewrite it. Check the first term. Is the first term a perfect square? Yes, of x. Is 36 a perfect square? Yes, of 6. The next thing you need to test is this negative 12. Is 12 2, and it's always 2 times 6 and x? Well, the answer is yes, it is. So we could take the shortcut here. You put your parentheses and you put a square on it. See how we're just jumping to the final answer. You put a minus sign on it because this was a minus here. By the way, never forget that has to be a plus because anything squared is always positive. And you simply fill in your numbers. X goes here, 6 goes here. If you don't memorize the shortcut, you don't have to use the shortcut. Okay, let's try the got it. Let's see if the got it would apply to the shortcut. X squared is the perfect square of x. 9 is the perfect square of 3. 6 is 2 times the 3x. This does apply to the shortcut. Give yourself a set of double parentheses. Carry down this sign that I'm pointing at. Put in x and 3. That's how you factor it. If you didn't remember how to, you would simply do it the long way. Digital images are composed of thousands of tiny pixels rendered as squares as shown below. Suppose the area of a single pixel is 4x squared plus 20x plus 25. What is the length of one side of the pixel? So what they're saying is number 1, okay, something important they're saying is that you have a square. Why would that be important? Because that means each side is the same. Alright, number 2, what did they give you? They gave you the trinomial. Trinomial is 4x squared plus 20x plus 25. They're asking you to write down the length, okay? So we know that we have length times width. They're asking you to find the length. Well, since they're the same, we're going to figure out if this thing applies to our perfect squares. 25 is composed of 5 squared. Be careful with 4x squared. You might not think it's a perfect square, but it is, because it's a perfect square of 2x. Check the middle term. Is the middle term 2 times 2x and 5? Well, 2 times 2 is 4, times 5 is 20. That works. Let's go ahead and factor this. We're going to use a positive sign in the middle. We're going to bring down 2x, and we're going to bring down the 5. So this is the area of the whole. So if we're just looking for a single side, we're just going to write one of them. And that's our final answer. Let's try the next got it. You are building a square patio. Again, the fact that they're telling you that it's square implies that they're going to be the same side lengths. The area is this trinomial. Realize that this entire area is length times width. What is the length of one side panel? Well, we're going to break this down the same way we did the last one. Square, meaning the sides are equal. So this should be a perfect squared trinomial. Let's work on 81. 81 is the perfect square of 9. 16m squared is the perfect square of 4m. 72, let's do our check. It's 2 times, let's hope it's 2 times these two items. So 4m and 9. Well, 2 times 4 is 8. 8 times 9 is 72. So we can put that a check mark. That's true. Let's get our binomial ready. This time we're going to have a minus sign in the middle. We're going to put 4m right there and 9 right there. So this is the total. If they're looking for a single, we simply write one of them.